the most ordinary gesture of urban life. Every day, millions of people in New York perform the same gesture. They turn on a faucet, and they trust. The water is always there. It rarely fails, and it is almost never questioned. But how does a city of this size receive water every single day? There is no sound of machines pushing the water, no motors working around the clock, no sense of effort. That is because New York, for the most part, does not rely on pumps to bring water into the city. The water arrives because it starts higher. It moves according to a simple principle: gravity. But it was not always this way. And to understand why New York works today, we must return to the moment when water began to run out. In the early 19th century, New York grows too fast, faster than its streets, faster than its institutions, and faster than its water. The city depends on wells and small local sources. As the population grows, these waters become contaminated. What once was enough is no longer safe. Disease spreads, fires become uncontrollable. Without clean, abundant water, the city reveals its fragility. The city comes to understand something essential. It cannot continue to grow by relying only on what surrounds it. The answer is given a name: the Croton Aqueduct. The Croton Aqueduct brings water from the north, from the Croton River Valley. The water is not pushed, it flows downward, moved only by elevation. The aqueduct transforms the city. Public health improves. Fires can be fought. New York begins to trust an invisible system. But New York keeps growing, and in time even the Croton Aqueduct begins to show its limits. The Croton Aqueduct solves an immediate problem, but New York keeps growing. And the city realizes something unsettling: the future will arrive faster than any temporary solution. The question is no longer, where can we find more water? But rather, how do we supply a future that does not yet exist? The answer requires a radical change of scale. Water must be sought not just outside the city, but hundreds of miles away, and not only far, but higher, much higher. Elevation is not a geographic detail, it is the key to the system. New York decides to build a system that will work before the city truly needs it. A system designed for decades, perhaps for centuries. A new set of systems takes shape in the Catskill Mountains and in the Delaware River Basin. The wager is simple and bold. If the water starts high enough, it will arrive on its own. What emerges from this decision is not merely an aqueduct, but an invisible machine operating on a continental scale. The system that sustains New York does not rise on the skyline. It has no towers, no smokestacks. It begins outside the city and moves invisibly. The water begins here, in reservoirs built at elevations higher than the city itself, high enough for gravity to do the work. From here, the water disappears. It enters the ground and travels through tunnels carved into solid rock. Hundreds of miles, a journey that takes days. No motors, no pushing. The water moves according to a single principle: difference in elevation. As long as the source remains higher than the destination, the flow continues. There are no moving parts along the way, nothing to turn on, nothing to turn off. The system does not depend on a single route. It was designed with redundancy, so the water can keep flowing even when parts must be isolated. By the time the water reaches the city, it has crossed a continent in miniature. By trusting gravity, New York reduces its dependence on energy, reduces points of failure, reduces complexity. The system works best when it goes unnoticed. But as the city grows upward, gravity meets a new challenge. For decades, gravity was enough. But New York did not grow only outward. It grew upward. The water that reaches the city arrives under pressure, but not infinite pressure. In ever taller buildings, gravity needs assistance. The answer does not come from a new central system. It comes from local solutions. At the top of buildings, New York adopts a simple, visible solution: rooftop water tanks. Water is pumped only as far as the roof. From there, it flows down on its own. This solution reduces complexity, isolates failures, and allows each building to manage its own pressure. Old and new buildings rely on the same principle. Technology changes, the logic remains. Rooftop water tanks may look outdated, yet they are part of one of the most reliable urban water systems in the world. When everything works, no one notices, but maintaining this balance requires constant attention. Even the simplest systems are not eternal. They keep working because someone takes care of them. Some parts of the system are more than a century old. They have crossed generations, and they remain in use. Unlike most construction projects, the water system cannot stop. Not even once. Every repair is planned for years, sometimes for decades. Not to improve what already works, but to ensure that it keeps working. When something fails, there is no warning sound, no spectacle. The greatest risk is precisely this: not noticing. Thousands of people work so that millions never have to think. The system works best when no one notices that it exists. At the beginning, it was just a gesture. Now it is an entire system. The water does not arrive by force. It arrives by decision, by planning, by trust in simple principles. The most resilient cities are not the ones that consume the most energy, but the ones that make the best use of reality. New York's greatest technology is not electric. It is gravity, and the intelligence to trust it.